Scholars, Miss Davy here to go over the 3.5 notes, quadratic equation, system of nonlinear equations. So you're familiar with this concept from 1.4. Here we were solving systems of equations. Here we were dealing with linear systems. So in this we had infinitely many solutions, no solutions, and one solution. The only difference we're going to be seeing here is we're now dealing with quadratic equations. Here are instances when we have no solutions, similar to when we were talking about linear equations. That's when our functions are not intersecting. So here are two examples where our functions are not intersecting. Here we have 1 point of intersection. That means we only have one solution here. And in the last example, we have two solutions. It's where the two functions are intersecting in two spots. So I want you to take a moment, pause the video, and try and decipher what these three are. So you should have come to the conclusion that the first is one solution, no solution, and two solutions. So let's look at an example when we're solving the equation. So here we're going to be solving by substitution, and then I will show you what that looks like in Desmos when we graph it. So for the first example here, I have y is equal to x plus 2 squared minus 3, and y is equal to negative 3. So when we have something that's set equal to something, we can say that y is the same as this, and we can also say that y is the same as this. We also know that y is the same thing to itself. So in that case, we can set these two things equal to each other. And now I'm just going to move this 3 to this side. This is where we need to solve for x. So we're applying those concepts of dealing with our squares. So the first step, since this is tacked onto my square, I need to move this 3 over here. Now I have x plus 2 squared is equal to 0. So now I need to take the square root of both sides, since I don't have anything tacked onto my base. This right here is my base. So this, now I can take the square root of both sides. When I take the square root, remember that these two things cancel out. And then the square root, we would have plus or minus. But when we have 0, there's no such thing as positive 0 and negative 0. So we're just left with 0. Okay, and then I'm going to move my 2 to the other side, which means x is equal to negative 2. So to find what my y value is, I would just take my x and plug it back into my function. I have no x to replace here. For every value of x, y is equal to negative 3 in this instance. When I plug it in, my x into here, I put negative 2 here. This whole thing goes to 0. So 0 minus 3, I have y equals negative 3. So here I have one solution at negative 2, negative 3. And here's the graph to show you that. So here's the two functions, and they intersect at one point here, and that point is negative 2, negative 3. Okay, my next example, I have y equals x plus 6 and y equals 1/2 times x plus 6 squared. Again, y is the same thing as this, y is the same thing as this, y is the same thing as itself. I set these equal to each other. So again, we want to get rid of what is tacked on with our base here. So what I'm going to do is I'm going to multiply 2 by both sides. So that way I can get rid of this half here. And that leaves me with 2x plus 12, because I'm doing 2 times x is 2x, 2 times 6 is 12. This 2 times this 1/2 gives me 1. 1 times this value here will just give me this value. Okay, so be careful here. I know a lot of you are going to instinctually want to take the square root here. A lot of you are going to want to do that. No, don't do that, because it doesn't make sense. If I take the square root of over here, there's nothing I can do to find a solution here. What you can do is you can expand this out, and then you'll be able to combine like terms. So when we go down here, I'm just gonna FOIL out this, and then here is when we FOIL it out, I get x squared plus 6x plus 6 plus 36. That's how I got this value right here. Okay, so now I can just subtract 2x from this side, subtract 12 from this side. Whatever I do to one side, I have to do it to the other side. And then when I do that, I get a 0 equals x squared plus 10x. 12x minus 2x is 10x. 36 minus 12 is 24. So now we can do factoring here, because we have this set to our quadratic here. When I factor this out, here's my magic x down here. I need to think about what I can multiply together to get 24, and then what I can add together to get 10. That would be 4 and 6. Okay, so in this form, and then you can double check this too. If I multiply this back out, I should get back to this, so just double check that. Now I have 0 is equal to x plus 4 times x plus 6. Well, for this to equal 0, I need either this to equal to 0 or this to equal to 0. When this is equal to 0, I have negative 4 as my x value. For this to be 0, my x value is negative 6. So my solutions are negative 4 here. If I put negative 4 into x, negative 4 plus 6, my y is then equal to 2. That's where I got the 2 here. And then negative 6, if I plug that into here, negative 6 plus 6, my y is equal to 0. That's where the 0 came from. So in this instance, I have 2 solutions. I wrote down the x, y here so that, just as a reminder, when I'm writing down a point, it's written as x comma y, so that you know what these values stand for as a reminder. And then when I graph that, you can see this is an example of where I have 2 solutions. I have a solution at negative 4, 2, which is right here. No, negative right here, this point right here. And then negative 6 to 0 is right here. Okay, so you're going to pause the video and try this one on your own. So this should be your solutions. Is when you set these equal to each other, then you get to this point right here. The common factor between these two is the 3x, so I factor the 3x out. 3x squared divided by 3x is x. Right? And then think about that. If I backtrack, 3x times x is 3x squared minus 3x. If I do 3x divided by 3x minus 1, or think about if I do 3x times 1, gets me back to the 3x here. And then for it to equal 0, I just set my x would be 0 here, or my x is 1. And then this is where you would find your 2 solutions. Next, we're gonna look at a process that looks very similar to elimination. Remember, in elimination, we're trying to get rid of our variables. So this example, again, I'm just gonna set these two equal to each other. And then what I'm gonna do is I'm just gonna get rid of one of these trinomials. And I'm gonna get rid of this trinomial here. So I'm just gonna add the opposite of the symbols we have here. So I'm gonna do plus 2x squared to get rid of this. And then I'm gonna get rid of this, and I'm gonna get rid of this. Whatever I do to one side, I have to do to the other side. So that leaves me with 0 over here. 2x squared plus x squared is 3x squared. Let me put that in a little clearly. That didn't quite look like a 2. Minus 6x plus 6. What do you see in common between these terms? Hopefully you said 3. So here I can factor out a 3 from each term. So dividing by 3 here leaves me with x squared. Dividing by 3 here leaves me with minus 2x. And then dividing by 3 here gives me plus 2. Now I can divide by 3 on both sides. That leaves me with 0 is equal to x squared minus 2x plus 2. Here, it's going to be, there's no way to factor this out since I don't have two numbers that I can multiply together to get 2 and then add together to get negative 2x. So here I would want to use the quadratic formula. Okay, so here I do negative b. So since my b is negative 2, it would be negative 2, which gives me 2, plus or minus the square root of 2 squared minus 4ac, a is 1, c is 2, divided by 2 times a. Again, a is 1. And this should actually be negative 2 because this is b squared minus 4ac. But then when I calculate that out, I get x is equal to 2 plus or minus the square root of negative 4 divided by 2. So in this example, I don't have any solutions. I at least don't have any real solutions. Here we have our imaginary solutions. And here is an example of our graph for that. So see, when I graph both of these, they don't intersect, which means I have no solution here. Okay. So let's do the next one. So here, these two are set up very nicely that we can just add them together. When I add them together, this gives me negative 4x squared. A positive y minus a y is just going to give me 0. 14x minus 14x is going to be 0 as well. When I add these together, I get 4. So then I'm going to divide both sides by negative 4. That leaves me with x squared is equal to negative 1. Then I can take the square root so that these two cancel out with each other. And then that is equal to plus or minus the square root of negative 1. But negative 1 is going to, again, give me imaginary numbers. So my x is equal to I or negative I. So in this example, again, no real solutions. If you want to, you can go ahead and graph these in Desmos just to double check it so you can see it. But I did not graph this one as an example. You can do that one on your own. And then the final example, I would like you to pause the video and try this one on your own. Again, you're going to try doing it with the elimination process and see what you get. So this is what you should have done. You're going to set these equal to each other. And it doesn't really matter which direction you went. You could have gotten rid of this side, or you can get rid of this side. For me, my brain was like, I want to get rid of this because it's not as pretty. So I just went to this side. So when I do this to both sides, I'm left with 6x squared minus 24x plus 18 is equal to 0. What do you notice in common with these three terms? You should notice that they all are multiples of 6, so that means I can factor out a 6 from each of these. When I factor out a 6, I get x squared minus 4x plus 3, right? So if I multiply this back in, I get 6x squared, and then 6 times negative 4x is negative 24x, plus 6 times 3 is 18. Okay, so I'm just factoring this out. So then I can go ahead and divide both sides by 6, and that leaves me with x squared minus 4x plus 3 is equal to 0. And in this instance, I'm able to, I need to think about what I can multiply together to get 3, and then what would add together to get negative 4x in that case. Negative 3 times negative 1 is 3, and then I add those together, I get negative 4x. So for this to equal to 0, I have x minus 3 is equal to 0, or x minus 1 is equal to 0. I get x is equal to 3, and x is equal to 1. When I plug those in to get my y, I get 3, 3 as 1 point, and 1, 3 as my second point. So here I have two solutions, and here is the graph for you to see that those are in fact the two solutions. So I just plug those functions in, and then here are my points, 1, 3, and 3, 3. Please be sure to bring up any questions you might have regarding these notes.